Let's say we wanted to solve this trigonometric equation, okay? And maybe this would be either very difficult to solve or possibly even impossible. So do we have any other options? What can we do? Well, these are the kinds of ideas that we discussed in numerical methods. So eventually there's going to be a playlist, a numerical methods playlist. But what we can do is we might not be able to get an exact answer, like an exact analytical mathematical answer to this, but we can still, there's a way that we can still get a very accurate answer here. And what I mean by that is it's in the same sense as, so we have no way of getting an exact answer to the sine of 12 degrees, right? As we've talked about. But in the background, the computer has a numerical method that it uses to where if we say approximate, we could get, to as many decimal places, within reason that we want, which is still pretty much we get the answer, right? So how can we do this? Well, first of all, I'll just imagine that this equation started off where there was, maybe you had x squared minus cosine x is equal to x cubed minus sine of x. It could have been in any form. And then from there, you take everything, put it on one side, and have 0 on the other side. Okay, then what we can do is we can graph this. X squared plus sine x minus x cubed minus cosine x. Graph that function. And I'll do that in Desmos right now. And there it is. And so you can see the solutions are going to be whatever this x value is, whatever this x value is, and whatever this x value is. And then, but as x goes to positive and negative infinity, the function goes off to infinity because of the x squared and the x cubed. So these are going to be the only 3 solutions to this equation. When you plug in these x values, you get 0. But in numerical methods, what we could do is this in Desmos, we could just zoom in really close here and see what the x and just get the most accurate x value that we can. So let me go ahead and do that. So if I zoom in on this x value, I could have zoomed more, but okay, we can see we have minus 0.869, minus 0.868, so minus 0.8685 is a solution. Again, it's not exact because we can't zoom in infinitely, but that's 3 decimal places, and we could go further if we wanted to. But in numerical methods, we learn more systematic ways of doing this. Instead of just zooming in on a graph, you could put that's what Newton's method is about, different things like that. You could put those kind of codes into MATLAB, or I think it'll work in Excel, specify the accuracy you want, and it'll calculate it. Okay, let's look at another example. Same idea here. You could have had all this mixed around an entire equation, but you bring everything to one side, set the other side equal to 0. You don't even technically have to do that. Like we could, another thing we could do is if, let's say you had 2 sine of 2x is equal to x cubed minus 1, you could graph 2 sine of 2x and then also graph x cubed minus 1 and see where they intersect. But it's one of the main ways to do like a numerical solve like this is you bring everything to one side and set it equal to 0, and that's like what Newton's method is based on. It's based on finding like x-intercepts. So that's why you'll see it in a form like this a lot. But technically, you could do this: graph x cubed minus 1, graph 2 sine 2x, and see where they intersect. But I'm going to go ahead and just graph this here: 2 sine 2x minus x cubed plus 1 in Desmos. Okay, and there you go. And we can see there's 3 solutions here. Whatever this x value is, wherever this x value is, wherever this x value is. Okay, same idea here. We can just graph this. We can say, bring the pi over 6 over and graph this. But when we graph an inverse trig function, it's going to have that range restriction. That's fine. That makes sense. Like we've talked about, we're not going to have to consider all of the possibilities. We can just treat this as the arc sine of x function minus the arc cosine of x function equals pi over 6. Let's solve for x. And there we go. There's going to be one solution. This is arc sine of x minus arc cosine of x minus pi over 6. That's what this is. And there's one solution. And if we zoom in really close, we can see about 0.866. So x is about 0.866. So that gives you a sense of how you can solve trigonometric and equations that contain inverse trig functions numerically. And really, but this also gives you some a preview of how numerical methods is going to work in general, not just for trig equations.